In today's hearing, we will examine opportunities for the use of innovative technologies in military construction. But first, I want to take a moment to welcome new subcommittee members. For the majority, I'd like to welcome Representative Alford from Missouri, who will be serving as Vice Chair, and Representative LaLota from New York. Joining the subcommittee for the minority from my great state of Texas is Ms. Escobar. Welcome. And from California, Representative Levin. This subcommittee serves the people who serve our nation and provides vital investments for the members of our armed services, their families, and veterans. We have a long history of bipartisanship on this subcommittee, and I'm committed to maintaining that tradition in this Congress. I urge all of my members of this subcommittee to keep this in mind today and in all committee hearings in the future. We're here today to examine the potential use of innovative technologies for military construction. While current military construction possesses and produces high-quality infrastructure, the construction timelines for projects may be lengthy and many believe that the DoD pays too much for what it buys. One study found that military construction cost premium was as much as 35% for some types of facility. Given today's fiscal challenges, we must find efficiencies that reduce construction timelines and costs. If we harness the power of new technologies, such as 3D printing, we can deliver high-quality infrastructure for warfighters and their families and be better stewards of taxpayers' money. Joining us today is four distinguished witnesses. Mr. Dave Morrow, Director of Military Programs for the U.S. Army Corps of Engineers. Mr. Keith Hamilton, Chief Engineer, Naval Facilities and Engineering Command. Mr. Thomas Healy, Chief Executive Officer for Hyliion Incorporated, and Mr. Brent Richardson, Principal Research Scientist of Energy and Infrastructure Environment for CNA. As a reminder to members, today's panel is here to discuss emerging construction methods, their facilities, feasibility, cost effectiveness, and durability. I ask you to refrain from discussions not germane to the reasons we're here. And now I'd like to recognize Ms. Wasserman Schultz for her opening remarks. Pardon my voice. Seems to be going south to Texas.
I thank the gentleman for yielding. Thank you, Judge Carter. Welcome to our subcommittee's new members and to our witnesses. I look forward to another year of working together to invest in quality services and benefits for our veterans, ensure our military readiness, and improve the quality of life for our service members and their families. And I appreciate the interest my friend Judge Carter has in this important topic, and I look forward to a productive conversation about the ways in which this subcommittee can help bring innovation into military construction. Before I address this hot topic, however, I want to take us back to the last fiscal year's hearings, where I, along with other Democratic members of this subcommittee, shared our concerns with reported proposals for 22% cuts to funding levels. At that time, there was a bipartisan consensus that cuts to the vital programs funded in this subcommittee should not happen. Yet now, a couple of months into the Trump administration, we are seeing cuts under a different name, implementing the illegal playbook of Project 2025. Under the guise of, quote, waste, fraud, and abuse, The administration is planning to cut 80,000 VA jobs and is canceling nearly 600 contracts, endangering veterans' access to timely and sufficient care and benefits. Beyond the VA, the administration is firing veterans in numerous agencies across the country and cutting other programs that veterans rely on, like SNAP and Medicaid. I refuse to let veterans and the direct services we provide to them be defined as, quote, government waste. That is utterly appalling and a complete betrayal of the men and women who have put their lives on the line in service to our country. Veterans and people who care for them are not government waste. These cuts and firings are causing immediate impacts on veterans like Ben, who was recently interviewed by the publication Task and Purpose. Ben is a disabled veteran who had a positive job performance review while working at the Department of Agriculture, where he helped other veterans with grants to fix health and safety hazards in their homes. Yet Ben was inexplicably fired in the careless, cruel approach President Trump and Elon Musk have taken to cut jobs across the federal government. Meanwhile, internationally, our allies are left scrambling as Secretary Hegseth focuses attention on Fox News culture war priorities rather than deterring Russia and our competitors abroad. The Secretary spent his first days banning books in DoD schools, restoring base names that honor Confederate soldiers, and banning qualified individuals who are serving honorably from serving in our military just because of their gender identity. If the goal here today is to promote innovative forms of military construction and improve the readiness of our armed forces, I would argue that indiscriminately firing 5,400 DoD employees is the wrong move. Improving our military installations' resiliency against extreme weather should be a priority, not firing generals for political grievances. Investing in construction methods that could speed the delivery of housing for our service members should be a priority, not spending nearly $50,000 of taxpayers' money to paint the Secretary's government-furnished house and pretending it's an emergency. Reducing the cost of our military construction projects should be a priority, not threatening tariffs on our allies, which we know will only cause steel and timber prices to skyrocket. I'm hopeful that we will have a fruitful conversation on the ways we can reduce barriers to alternative construction methods and drive innovation in military construction. The length and expense of the military construction process, as my friend Judge Carter mentioned, is a challenge, and it impacts the number of projects which can be funded in any given year. This problem only grows more acute as the services are increasingly building in expensive, remote areas like Guam. I hope the ideas we discuss here today can be a part of the solution to these increasing costs and to the costs over the full life cycle of our military facilities. Moreover, we know the devastating impact natural disasters had on military bases in recent years, from hurricane damage in my home state at Tyndall Air Force Base and MacDill Air Force Base after Helene and Milton, to the devastation on Guam from Typhoon Mawar. We cannot bury our heads in the sand and ignore the climate threat to our military installations as well. Investments in resiliency now will save us billions of dollars in recovery later on. Some alternative building materials, like mass timber, represent a possible solution to making installations more resilient to extreme weather events, while also reducing the service's carbon footprint and contribution to the climate change problem. When it comes to mass timber products, details matter. For mass timber to truly be a part of a climate solution, it must be sourced in a sustainable way. When this does occur, mass timber products provide a benefit of carbon storage, as well as reduced carbon emissions compared to traditional materials like concrete and steel. But I have concerns with how this administration has already been stewarding our land and resources, recklessly clear-cutting forests, cutting down old-growth trees, or ignoring the Endangered Species Act and other environmental laws is short-sighted and dangerous and will not advance our goals that we have here in this committee. I'd like to thank the four witnesses for being here today and for their expert testimony, and I yield back.
Okay, we'll now turn to our witnesses for today. Without objection, your entire written testimony will be included in the record. I will now recognize each of you for an opening statement, and we will then proceed with questions. Mr. Morrow.
Chairman Carter, Ranking Member Wasserman Schultz, and distinguished members of the subcommittee, thank you for this opportunity to discuss the U.S. Army Corps of Engineers' efforts to research and utilize innovative technologies, techniques, and materials in military construction projects. Over the last 2.5 centuries, the U.S. Army engineers have evolved to provide engineering expertise to the Army and to respond to the nation's toughest engineering challenges. The USACE mission includes civil works, military programs, research and development, and disaster response. Today, I want to focus on our military programs and research and development missions. We support our combatant commanders in 110 countries around the globe through military and international services programs. We support 3 million active duty military, veterans, civilians, and their families. USACE relies heavily on the private industry to deliver innovative technologies and techniques in military construction. The Unified Facilities Criteria, or UFC, are developed through a tri-service coordination that sets basic technical requirements that must be followed to deliver a code-compliant, complete, and usable military facility. Any innovative design solution that meets the UFC and mission requirements is acceptable, and USACE encourages design and construction solutions from our industry partners that meet these requirements. Our research and development mission, vested in our Engineering Research and Development Center, or ERDIC, is to discover, develop, and deliver trusted engineering and scientific solutions for the warfighter and the nation. ERDIC provides engineering technology leadership necessary for force protection, force projection, sustainment, and civil works missions. The USACE organizational structure supports delivery and innovation through 44 districts that execute construction projects for the local regions. USACE has regular engagements with the other military services, which fosters innovation through information sharing and common training opportunities. This allows USACE to benefit from the experience of a diverse project execution and leverage those lessons in military construction. So one technology that can be used for expeditionary, CONUS, or MILCON applications is additive construction, or construction 3D printing. Additive construction has potential to reduce costs, manpower, logistics, and time, while opening the door for improved and new applications such as unconventional countermeasures. ERDIC has taken a leading role in acceleration of technology transition with the private sector. This includes development of UFC language to allow additive construction in 80% of the United States and in regions where seismic activity is not an issue. This is still a developing technology. Pilot projects at locations such as Fort Bliss, Camp McGregor, and Tyndall Air Force Base have led to increased confidence in additive construction in military structures. To expand this technology for higher risk areas, a consolidated testing effort needs to be completed. ERDIC is currently conducting research and field demonstration projects on innovative cement solutions utilizing non-traditional chemistries. Advantages of these products can include rapid set hardening times, supply chain advantages, and activated chemical solutions for protection against specific threats. Synthetic polymer materials called geosynthetics are being designed and manufactured to solve civil engineering problems, including separation, filtration, drainage, reinforcement, and containment. USACE has supported testing and evaluation of mass timber materials. We recently designed the Army's first barracks made primarily with mass timber structural elements and are soliciting interest in construction of a project at Mountain Home Air Force Base calling for the incorporations of mass timber design. Utilizing mass timber in these projects may reduce construction timelines. Fiber-reinforced polymer composites are under investigation to meet military interest in corrosion-resistance, low-maintenance critical infrastructure. In an increasingly complex global security environment, our commitment to innovation in military construction is not just about building structures, it's about building the resilience and readiness our forces need to prevail. By working with industry to leverage these advancements, we can deliver more durable, sustainable, and cost-effective infrastructure for our military, ensuring taxpayer dollars are used efficiently while equipping our troops with the best facilities in the world. Thank you for your time today, and I look forward to your questions.
Thank you. Now we'll turn to Mr. Hamilton.
Thank you, Chairman Carter, Ranking Member Wasserman Schultz, distinguished members of the committee. Thank you for the opportunity to testify on how Naval Facilities Engineering Command, or NAVFAC, is leveraging innovative construction techniques and technologies in military construction. NAVFAC has a worldwide team of dedicated engineers and architects, planners, project managers, contracting officers, and other professionals who design, maintain, acquire, and construct facilities and infrastructure to support our warfighters at home and abroad. We are continuously collaborating with industry to identify and implement new innovative infrastructure solutions and to apply industry best practices that help make our U.S. warfighters more lethal, adaptable, effective, and resilient. NAVFAC is actively testing and employing innovative technologies, materials, and methods for design and construction today, and we are leaning forward to increase collaboration with industry, academia, and other government partners to identify and leverage future opportunities. I'll provide a few examples. We realize that we must think, act, and operate differently in order to meet the many time-critical fleet and Marine Corps missions and requirements that we face today. This includes the employment of new and innovative solutions to reduce the cost and increase the speed of infrastructure project delivery. To address this issue head-on, we've developed an acceleration and affordability campaign plan, and as a part of implementing that plan and in coordination with our Navy Installations Command, we've issued guidance that at the start of every new military construction project, NAVFAC's planners and engineers are required to evaluate whether the project can use alternative construction methods to meet the warfighting mission requirements while driving lower costs and accelerating the project delivery. For many of our projects under construction today, NAVFAC uses some form of industrialized or modularized construction to prefabricate facility components at offsite private fabrication yards. We see tremendous benefits in this technique, and we see it as an opportunity to employ this approach. We're working to expand its use and to be able to leverage it for far greater economies of scale. We think this scale can be achieved by using industrialized construction for facilities where we have standard designs and repeatable modules that can be grouped in programming and acquisition, then constructed at the offsite fabrication plants and brought to the project site for final assembly. In fact, we're using the other transactional authority that Congress provided in 10 U.S.C. Section 4022 to pilot development of an industrialized construction project that will build a child development center in Little Creek, Virginia. We then hope to scale that pilot approach to a number of child development centers that will be constructed in the Mid-Atlantic and Southwest regions in the next few years. NAVFAC is closely following and is keenly interested in applying additive construction methods, or 3D printing. We've seen tremendous advances in the technology, and we see continually improving capabilities and costs that are achieved through these methods. NAVFAC is also piloting the use of new and improved materials for use in military construction projects. We're constructing a Navy Child Development Center in Hampton Roads, Virginia that uses cross-laminated timber. At Marine Corps Air Station Cherry Point, we're piloting the use of high-performance concretes in a major new F-35 hangar and aircraft sustainment center. NAVFAC is working to expand our use of various types of composite fiber-reinforced polymers, particularly for retrofitting and strengthening existing structures. NAVFAC is working to identify and develop near-term and long-term applications exploiting the power of artificial intelligence, or AI. We are partnering with the National Renewable Energy Lab and National Institutes of Building Sciences to identify use cases where AI can be employed in the planning, design, and construction to increase efficiency, reduce costs, and accelerate project delivery. We're also exploring potential efficiency tools with several leading AI companies, including early capabilities in generative AI for planning and design. Finally, in addition to using the Section 4022 Other Transactional Authority, which has shown real value in identifying and leveraging industry innovation, NAVFAC is exploring the use of alternative delivery methods such as progressive design build, lean design build, and construction manager at risk. These approaches are being used in the private sector to encourage innovation, speed project delivery, and reduce cost. However, we're finding that there may be statutory or regulatory changes that are needed for us to fully leverage these approaches. Thank you for the opportunity to testify today. I'm proud to be a part of an organization that continuously pushes engineering boundaries to provide affordable infrastructure for the DoD that helps to ensure the lethality, resiliency, safety, and warfighting effectiveness of our military forces. I look forward to your questions.
Thank you. Mr. Healy.
Chairman Carter, Ranking Member Wasserman Schultz, and distinguished members of the subcommittee, thank you for having me here today. I'd like to start off with a question. What if our military could produce electricity through a mobile generator that provided better electricity than even the U.S. grid? Well, I'm here today to introduce a new superior power generation technology, one that's reliable, efficient, fuel flexible, and mobile. I founded Hyliion out of my dorm room at Carnegie Mellon, and it's been an American startup story. We took the company public on the New York Stock Exchange in 2020. We raised over $700 million of capital, and we've begun delivering our Carno modular power plant, which we believe will fundamentally change how electricity is produced. If there are three key things to remember about what we're doing, it's first, that it's one solution that can be used across all applications. Second is it offers fuel flexibility, reliability, and the performance the military needs. And the third is it's manufactured through 3D printing, which enables us to make it here in the US. So let's go back to that first point about one solution across all applications. What if military vessels, autonomous vessels, what if bases, what if vehicles could all use the same power generation solution, leveraging the same parts and the same service across all applications? The Carno generator is designed to be scalable as well, starting with a 200 kilowatt base unit that then can be stacked together to deliver multi-megawatts for military bases. That base unit, just for reference, is about the size of a bed of a pickup truck, so it's extremely compact. This vision is already becoming a reality. We actually just delivered our first unit to the Navy, and they're going to not only be testing it for autonomous vessels, but they're also going to be testing it for stationary applications. The second point I made was why Carno? So this is a fuel agnostic solution. It can operate on over 20 different fuels, including diesel, natural gas, propane, JP8. So imagine if our troops are deployed somewhere in the world where it's kind of unsure of what fuel they're going to have available to them, and it's unsure if that fuel is even contaminated. Our technology eliminates those concerns because now the system, you start feeding it fuel, and it will sense what fuel it's receiving, adjust accordingly, and deliver electricity. Now, reliability is also key. So the system's designed with only one moving part, and even that part glides on gas bearings. It's similar to like an air hockey table. So that eliminates the need for oils, eliminates maintenance or substantial maintenance, and eliminates lubricants. So as you think about like autonomous vessels where there isn't anyone on board to actually maintain the engines, reliability is critical. Additionally, we want to look at efficiency. So the Carno generator, when you compare it to the grid is about 36% efficient. So, your standard wall outlet. The Carno generator will be able to deliver efficiencies up to 50%. That means that we're going to use less fuel to make the same amount of power. Now, it does all these things while also having a very low noise profile. It's similar noise level to like an air conditioning unit. And it also has a low heat profile, meaning the system is less detectable. Any one of these advantages alone could convince you to move away from diesel generators, but we've been able to package all of this into one solution, our Carno generator. So the question comes up of like, well, why hasn't this been done before? And that brings me to my third key point, which is 3D printing. So if you go back 200 years ago, there were steam engines, there were diesel engines, there was this thing called a Stirling. Engineers always knew that Stirlings could be or would be the most efficient way of making power, but you could never manufacture a Stirling. Fast forward to today, thanks to advancements in 3D printing, we're able to make parts like this one here that are extremely complex, allow us to unlock efficiencies that now make Stirlings a reality, or as we like to call it, the Carno generator. So I think this is going to be passed around. So I want to be transparent with where we are in this process. As I shared, we just delivered our first unit to the Navy, and we have other early adopter customer units planned through the middle of this year. We believe the system will deliver everything I've shared today, but we are still in the final stages of development. We're testing the system and continuing to refine it. So as we go forward, we'd like to expand our relationship with the military, especially as we start scaling. We've already set up manufacturing both near Austin, Texas, as well as in Cincinnati, Ohio. Yeah, Austin. And so that is going to ensure that this is domestically produced. Chairman Carter, Ranking Member Wasserman Schultz, and distinguished members of the committee, our military has been known for having the best technology and we need to make sure that remains true for power generation as well. With Hyliion's Carno power plant, we're delivering the three key things that are important. It's one solution that can be used across all applications. It offers fuel flexibility and reliability, as well as it's made here in the U.S. thanks to 3D printing. Thank you.
Thank you, Mr. Richardson.
Chairman Carter, Ranking Member Wasserman Schultz, distinguished members of the committee, thank you for the opportunity to testify on innovative military construction techniques. CNA's Center for Naval Analysis provides our sailors, our Marines, and the broader national security community with objective analytics to improve the lethality and effectiveness of the joint force. Our sole mission is to support the decision-making of military leadership. The study we conducted for Deputy Assistant Secretary of Defense for Infrastructure, Modernization, and Resilience included the identification of barriers to innovative construction techniques in MILCON. This study was important because the results showed that a forcing function to use such techniques should be developed. There are several options to bridge the gap between industry and DoD efforts to adopt innovative construction techniques. First, a DoD technology roadmap for MILCON would provide necessary guidance for both DoD and service component labs to make informed and targeted investments toward innovation. Such a roadmap would establish enduring capability needs and measured focused areas for identified MILCON outcomes. One specific use case, for example, is to leverage artificial intelligence technology to provide a scalable, faster, and reliable aid for design and construction management efforts. A published MILCON technology roadmap would also provide a demand signal to industry to drive development of specific technologies, potentially leading to private sector investment. This could also foster the subsequent development of industry standards and best practices, thereby advancing the further adoption of innovative techniques. A second recommendation is to adhere to a collaborative, front-loaded design process. This would entail the inclusion of construction contractors early in the design process for the purposes of leveraging additional innovative construction knowledge and experience that is newly emerging in the private sector. Industry experience shared by a construction contractor during the design phase of a project can provide valuable benefits to the government, including the identification of regionally available innovative technologies, and the supporting workforce. Construction contractors with regionally specific expertise can also serve as a resource in the identification of potential construction challenges in the design phase. This allows the designer of record to minimize construction risks and facilitate the most efficient construction means and methods. NAVFAC, Naval Facilities Engineering Systems Command, has undergone such efforts and recently published a guide for early contractor involvement in the design phase of MILCON projects. Lastly, while our analysis highlighted existing DoD efforts toward the inclusion of innovative technologies in MILCON, such as additive manufacturing and mass timber, without a technology roadmap in place and industry engaged in the design phase, DoD investment in such technologies is not prioritized and private sector interest is not encouraged. Thank you for the opportunity to speak today. I look forward to your questions.
Well, thank you very much. And I'll start out with the Army. Mr. Morrow, these new technologies like 3D printing and additive manufacturing hold a promise. Where is the Corps stand on the actual use of these? And what research do you have on their reliability and strength in both cold and hot weather?
Thank you. Thank you, Congressman, for that question. So currently, the UFCs allow additive construction or 3D printed construction in seismic zones A and in seismic zones B with a shake table test to demonstrate that the means and methods for that are structurally sound. So in those areas, we're completely supportive to go into higher seismic zone areas or multi-story buildings. I think additional testing is required. So our ERDIC, our Research and Development Center, they're working closely with industry. They have continuing efforts to demonstrate that material and advance that material. But for routine military construction, if, for example, a design build RFP is for a single-story building in seismic zone A or seismic zone B, there's nothing that would preclude industry from proposing on that. So recently, the Navy and the Corps developed some joint training for our project managers, our technical staff, and our acquisition teams. Part of that training was innovative construction methods and innovative construction material. So we want to, continue that education and ensure that out in the field where the real work is done, our team members are cognizant of new emerging technology, and when they're evaluating proposals and planning projects, they're keeping those in mind as well. Thank you.
Anyone else want to comment on? I know we're all talking about seismic, and that's important. But what about the various heat levels? Would it be what you're making be viable in Alaska or in the Arctic, as well as where I live in Texas, where it's hot? That's a good question. I like, as you've talked about what you're doing, are you looking into those things? Because I think that's very important.
I can maybe share a little bit about that. So just going back to your last question of the reliability of 3D printing. So that part I shared was made through 3D metal additive. Chances are if you flew to DC, greater than 50% chance the plane you were flying on was powered off of additive parts. So this has already been approved by the FAA. It's being used regularly. So additive is real. It's happening. It's being leveraged today. In terms of the ability to operate in different environments, that part that got passed around is made out of cobalt chromium, one of the most resistant metals to heat and cold as well. And so our system is designed to be able to operate in the extreme cold, like -40°C, as well as north of 40°C. Right, so that means it can go to Alaska, it can go to Texas, and actually one of the unique things is it actually likes the cold. It actually performs better in the cold. So we're actually looking forward to a Navy deployment that is going to be going to Alaska.
Any others want to comment? Okay. Navy, want to comment? Mr. Hamilton?
Thank you, Chairman Carter. I just add to the comments the gentlemen have made that I think first the additive manufacturing is very highly developed, and we use it extensively to manufacture parts. We use it to manufacture parts that are no longer obtainable in the market. We use it for troop deployments where we can do things in an expeditionary environment. Additive construction is a very promising technology and has developed very substantially over the last several years. And I think to your question about how is it applied in different temperature zones, I think we know more about its application in warm temperature zones. I think temperature is certainly dependent on the types of mixtures that are being used for the additive construction. That has to be carefully monitored and maintained. We have less experience with it in cold weather environments, but I think all of those environments are important for the future development. We believe this is a technology that will have great use as we go forward, and especially as we begin to address some of the seismic issues that would allow us to apply it in the Indo-Pacific regions.
Thank you for bringing that up, because it's one of the questions I wanted to ask. I visited the Indo-Pacific, and so has my colleague, and they've got a lot of issues over there. And if one of it is that sea climate. It's very hard on buildings. Do you have are you building anything in that area where you know how it's affected by the ocean and the constant humidity and all the things they have at Kwajalein, let's say?
Yes.
Guam.
Yes, sir. Thank you for that question. We, as you know, have a great deal of work across the entirety of the Indo-Pacific theater. And in Guam, as you mentioned, we have a very large construction program. We have a lot of infrastructure that is aged and damaged that we are working to repair and to harden. And we're using a wide variety of techniques and approaches to do that. We have to be very sensitive to not just seismicity in the area. We have to be, of course, very mindful of the typhoon conditions that facilities have to endure in those locations. We have to, as you pointed out, understand the impact of the saltwater conditions and other things that they're exposed to. And so that limits some types of materials. We find that some steel materials, if they're going to be used in that area, have to be specially prepared for that kind of environment. If they're not, and we've certainly had steel components that have deteriorated very quickly in that environment, we're beginning to look at the use of various fiber-reinforced polymers that can be used in that kind of environment. There are some promising developments, including panelized construction that is very resilient in those kinds of environments, and it's also very strong, has the ability to put fibers that provide different capabilities within that particular panel that is developed, so that it might provide RF shielding for skiffs, or it might provide armor or explosive resistance for different types of applications. So we find that to be a very valuable technique there. And the other thing that I would mention is that we're looking very hard at industrialized construction, the ability to prefabricate components in the United States and have those shipped to those regions in the Indo-Pacific theater for installation on the project sites. And we find both cost and timing benefits of that application.
On the concrete that they make with the 3D printing, do you have if you're doing that over there and on the islands, you got lots of sand, but do you have any gravel or any other source to make that concrete viable, or will it have to be shipped in there?
Yes, sir. We've done testing with additive construction, working with both ERDC and with the NAVFAC's Engineering and Expeditionary Warfare Center to see if we could use native materials. We did a pilot project in Guam where we used all native materials to do the additive construction, and it was very successful. We did blast testing with those facilities, which were very successful tests. We saw it stood up very well. We've also worked with saltwater concretes so that for expeditionary use, not for long-term permanent facilities, but for expeditionary use, our troops can go in and use salt water rather than fresh water that would have to be brought in or purified on site to make the concrete. And we've found very similar characteristics in terms of strength and durability for a short-term 1 or 2 year construction that we might expect in an expeditionary contingency environment.
Thank you, Ms. Wasserman-Schultz.
Thank you, Mr. Chairman. I've been the ranking member or the chair of this subcommittee since 2014. And most of that time I was serving alongside Judge Carter. I think if he and I had a nickel for every reprogramming that we have signed in our roles due to increased construction costs, increased labor costs that were unanticipated by the military, we could retire. And President Trump has announced a 25% import tax on steel and aluminum, in addition to a broad range of other tariffs against countries like Canada, Mexico, and China. During this hearing, he announced an additional 25% tariff on aluminum and steel against Canada. These countries are retaliating. They are levying tariffs in response and boycotts. Among the wide range of negative inflationary effects these unnecessary actions will have on our economy, they'll undoubtedly lead to our needing to sign more reprogramming requests due to increased unanticipated costs. So I'd like to hear from each of you what impact you expect to see on material and construction costs as a result of the newly announced tariffs on products like steel, aluminum, including the potential impacts on labor costs, which American companies rely upon. Mr. Morrow, you can start.
Thank you, Congresswoman. I think the first point I'd like to make is we've put a tremendous amount of emphasis on our project planning process and reducing the risk and getting all of the information possible for the site exactly to minimize any future reprogramming. So many of the efforts to advance a project to a 35% design, get a better cost estimate, et cetera, is already starting to pay dividends. So hopefully we'll have fewer reprogrammings based on unanticipated costs. I think it's really too early to tell how the market is going to respond to many changes. And one of the shortcomings of cost engineering is we have lots of historical data, but we can't look precisely into the future. So our cost engineers follow the markets very carefully, try to incorporate all of the risk-informed decision-making they can into developing those estimates. But I think it's really too early to tell.
Mr. Morrow, are you really telling me that an unanticipated 50% tariff on aluminum and steel is not going to, you're not sure whether that would cause unanticipated increase in costs to military construction projects?
It depends, of course, project by project, where, obviously we follow the Buy America Act, and most of our material comes from this country. We're talking about other technologies like mass timber that could replace steel or concrete structures. Every project is individual, and
Right.
I think the most
Okay.
important thing we can do is to try to get the number right in the first place so that everybody has decision space to make the appropriate
Unfortunately,
decision.
all of what you're saying is true, and yet we still regularly have to are presented with reprogrammings that are the result of unanticipated costs. So the system you're describing isn't working, isn't improving, and so isn't working, isn't improving, and it's just hard for me to believe that you're. I know you're being truthful, but it's hard for me to buy that you're not sure whether 50% tariffs on aluminum and steel are not going to result in increased costs. Mr. Hamilton?
Thank you, Ranking Member Wasserman Schultz, for the question. I think I certainly acknowledge the challenge that you highlighted with cost estimating, and especially in dynamic, changing times in the markets. We've done a number of things to try to address those challenges. As Mr. Morrow identified, we've put a focus on better understanding market conditions and being able to predict them and incorporate them into our cost estimating processes. We have a chief economist that tracks all those economic trends and builds them into our building cost indexes that we apply to our projects. We've advanced our development of cost schedule risk analysis, are working to mature designs. I think the innovations that we're talking about today in terms of materials and alternative construction methods is something that helps us deal with some of the specific market turns, whether it might be concrete or it might be steel or various construction materials that have perturbations in cost. We now have more alternatives to be able to use cross-laminated timbers or to be able to use tension fabric structures or printed concrete materials and other things that help us avoid.
There's only 2 pilot projects per service on materials like that. So there's certainly not widespread use of those alternative materials. And so we're talking about the immediate impact of a 50% tariff on the materials that we are currently using. So, but you're describing certainly in the long term when we move away from these kinds of materials. But it's hard to wrap my mind around the idea that I realize no one wants to say what it is. The real answer is because we all know what it is. It's pretty obvious. Mr. Richardson?
Thank you, Wasserman Schultz, for the question. I was prepared to talk about potential barriers to including more innovative construction techniques in military construction. We didn't examine specific technologies, so I would say that these increased tariffs could potentially force us to be more innovative in employing construction methods that could be used in the United States.
Which would result in job losses, because if we're shifting away from the industries that we typically use materials from because they're too expensive, then obviously people will lose their jobs. Mr. Chairman, I have just one other question. From my home state of Florida to the far shores of Guam, our military installations face a greater threat than ever before from extreme weather events that are driven by climate change. Military construction, obviously, we've realized has to take into the account the danger of wildfires, hurricanes, severe storms, more depending on the location of projects. We have to increase our investments in resiliency now, because even if building resiliency into these projects is costly, we know doing nothing results in far greater cost to rebuild damaged and destroyed infrastructure. So, Mr. Hamilton and Mr. Morrow, what steps are you taking to ensure that all military construction projects prioritize resiliency, and how might alternative materials like the ones mentioned today play a role in improving the resiliency of our infrastructure?
Thank you, Ranking Member Wasserman Schultz, for the question. I think there are many things we can do and are doing to address this. I think it starts with understanding where we need to have different kinds of materials to withstand the kinds of environments that we are witnessing today. And some of the materials we're talking about today are specifically designed to deal with those harsh environments. We're making sure that we are focused on updating our unified facilities criteria and guide specifications that incorporate those kinds of materials into the projects that we design. We're making sure that we harden areas, for example, as we try to recover from the Typhoon Mawar in Guam, to harden the utility systems, to make them more resilient, more able to withstand the kinds of weather impacts that we have been experiencing, and make sure that we're prepared. We have redundancy in our systems where that's necessary to be able to continue military operations in the face of those kinds of events.
Thank you.
Just, Congresswoman, two points. One, I would use Tyndall Air Force Base as an example. Obviously, that installation was devastated following a hurricane many years ago. There's been a tremendous amount of construction there, and those new facilities have fared very well in subsequent storms. So I do think we're learning lessons and we're continually improving. Another strength that the Corps of Engineers has is our civil works mission. So we do a lot of coastal storm damage reduction projects, other projects of that nature. So when there are coastal installations, we've got that technology and that subject matter expert base to lean on. And if it's a Navy or an Air Force project, we work collaboratively all the time to make sure we're putting the right professionals to address those types of issues.
Thank you. Thank you, Mr. Chairman. I know you and I have seen the impact of the saltwater erosion and intrusion in the Pacific and in Florida. We have MacDill and Tyndall that are, right on the water and are regularly exposed to the risks. So we need to make sure we're continuing to focus on resiliency. Thank you.
Thank you, Mr. Chairman, and thank you to all of our witnesses today. And I'll ask you to give me a little grace on my voice as well. But I want to go back to the supply chain issue for a moment, because I think it's very important, not just in light of tariffs, but after COVID-19, we saw how fragile all of our supply chains are. And one of the things that we have done, I'd like to ask you, Mr. Hamilton, one of the things that we've done in HUD is on some programming, we have allowed them a 2-year appropriation. And the response has been very positive. Can you talk about how, a couple things. How would that help with your supply chain issues with cross-laminate timber, for example? I know they did a project up in Joint Base Lewis McChord. I think Mr. Richardson talked about that. Can you talk a little bit about what that might mean to cost and development?
Yes, sir. Thank you, Congressman Rutherford, for the question. We do struggle today as our construction projects are more and more costly, especially with our O&M appropriations, which are one-year appropriations. Today, the average cost of our large O&M funded projects are larger than the military construction projects we funded not that many years ago. And so as we look at those projects, we also find that both for military construction and O&M funded projects, we have many specific components and equipment, sometimes materials that are long lead, sometimes a year and a half, 2-3 years for substations and electrical switchgear and other things. So the ability to have that equipment purchased in advance so that it's available when the construction project needs it is really important to allow the project to be able to finish in a timely manner. The length of appropriations is challenging because as you execute a very large O&M funded appropriated project with the expiration of the funds, you're both squeezing it on the front end and often challenged to have a large number of those projects all going out to competition at the same time in the latter part of the fiscal year. And then you're executing it after the appropriation has expired. So especially on those repair projects, you encounter unforeseen conditions, and those conditions, there's no longer a current appropriation to fund those changes. So you have to reach back to previous appropriations, often delaying the project, raising the cost of delivery. So multi-year O&M appropriations would be very helpful to alleviate that issue.
It's worked very well in HUD, Mr. Chairman. That's something we may want to look at also. Mr. Healy, I am really, thank you, Mr. Hamlin. I am really intrigued by your development. One of the things that I'm really concerned about for America's defense is, these electromagnetic pulses. And is your generator protected from those EMPs? Or can it be?
Yeah, thank you, Congressman. Today, it is not protected from EMP attacks, but what I will share is through our journey, we've been working with the Navy, and the Navy has continued to give us military specs that we need to be able to meet, and then our engineering team goes and achieves those. A perfect example is Navy's going to run on diesel fuel. They wanted to be able to run on up to 20% contaminated with salt water diesel fuel. So then we go and we engineer the system to be able to do that. So that's something if the military is interested in, we'd be happy to explore.
That is pretty amazing, actually. I'd like to ask Mr. Morrow, in the 2025 NDAA, we allowed, I forget the section, let's see, we allow you to now use O&M instead of MILCON for budgeting for some of the beach erosion, other types of erosion in our military facilities, like Blunt Island Command in Jacksonville, where we've got some erosion on the island. And is the Navy planning on using that moving forward? Is that all you need to start using O&M?
So anytime we have more flexibility on the types of projects we can fund, whether MILCON or O&M, it makes us more responsive and more flexible. I'm not familiar if we have, so when the Corps executes O&M, whether on behalf of the Army or the Navy, they do it on a reimbursable basis, and our organization is funded by those projects. So we've had a number of recent changes to the O&M rules that have all been very, very helpful. So the most recent is in barracks, so we can now repair a barracks through a replacement of a new facility. That's a pilot initiative that...
Okay, Mr. Morrow, I hate to cut you off, but I see my time has expired. But I will tell you, I found it. It's section 2847. So if we could look at moving those projects forward, especially at Blunt Island Command. Thank you.
Yes, sir.
I yield back.
Man, I'm losing my voice. Mr. Bishop.
Thank you very much, Mr. Chairman, and let me thank the witnesses for their testimony this morning. Let me start with Mr. Morrow. As you know, Georgia has the largest stand of privately owned timberland in the nation, and we're proud of our efforts to be good stewards of the land and produce environmentally friendly materials that directly contribute to sequestering greenhouse gases. And the advent of mass timber, the building material made from multiple layers of wood that you've described, is amazing. It's an innovation, high quality, low cost, efficient, environmentally friendly building construction. You're now able to build much larger and taller structures with this engineered wood. In 2023, the Corps announced a new policy of considering at least one option where mass timber is a substantial structural component. We're comparing structural systems during the early design of vertical construction projects. Can you give an update of the new policy and if you've seen an increase in the usage of mass timber in construction projects? And do you have any suggestions on how we can reduce the remaining barriers to the adoption of mass timber in military construction projects?
Yeah, thank you, Congressman. So quick update, we are at 100% design for a mass timber barracks at Joint Base Lewis McChord. And so that's an FY25 MILCON project. So if we have an appropriations bill to execute that work, we're poised to do that right now. But you're absolutely right. Over the last few years, there is much more code compliant mass timber, cross-laminated timber capability. So we are encouraging all of our designers and on our design build construction contractors to bring to the table any innovative technology that's both code compliant and meets the mission. And so as commodity prices change, as the economic circumstances on the ground change, that's when industry, we want to give them the most flexibility to bring the best ideas to the table, to safely deliver quality projects on time and on budget. So we really rely on our industry partners, to be as innovative as possible.
You mentioned if we get an appropriations bill. With the majority pushing for a full-year continuing resolution, I'm very concerned that the lack of certainty and direction from Congress may severely hamper our armed services. So I'd like to hear from you how this would affect MILCON projects that are currently in progress or those that are projected for 2025 completion. Would a full-year CR delay future projects? We have 2 in Georgia for FY29. Would those be pushed back?
So if we weren't allowed new starts, my understanding is the current bill under consideration does allow new starts for military construction, but until it's passed, we won't know.
Okay, one other follow-up. The NDAA for FY19 required the Department of Defense to stop purchasing PFAS by October of 2023 and to stop using them completely by October of 25. What advancements has the Corps of Engineers made in this area as the deadline is quickly approaching? What testing is being completed on new materials so we won't find ourselves in the same situation years down the road battling hazardous materials?
Yes, so we've been prohibited from using PFAS or PFAS-containing materials primarily in AFFF or aqueous firefighting foam since 2016. However, our legacy systems, we need to decommission them, upgrade them to new systems, and we've been, we're on a path to do that. The final set of contracts to execute all of that recommissioning and upgrading those AFFF systems are ready for contract award this year. The current price tag, our estimate is about $56 million. It's not yet been funded, but we're ready to execute as soon as funding is made available. Again, the Corps executes these projects on a reimbursable basis for the Installation Management Command.
Thank you. Mr. Hamilton, can you tell us what you've been seeing with regard to the use of mass timber with the Navy?
Yes, sir. Thank you for the question. We also are doing a pilot project with cross-laminated timbers. Ours is a child development center in the Hampton Roads, Virginia area. That project is in design and will soon transition to construction. We found a lot of advantages to the cross-laminated timber. It's lighter than steel or concrete. It has resiliency features. It is actually very, compared to other wood components, very good in fire and even blast resistance. But one of the big advantages we've found with it is it can be manufactured in a manufacturing environment which is very precise, cut with digital equipment and brought to the site in very precise component shapes and sizes and installed there, often saving time of in-field construction. So we see this as an opportunity for future use in a number of different ways. And as you mentioned, now available to be used for higher, taller buildings than we had approved it for in the past.
Well, thank you very much. I think my time has expired.
Ms. Dice?
Thank you, Mr. Chairman, and thank you to the witnesses for being here with us this morning. Let me first start out by saying that I'm proud to represent the Oklahoma City metro area, which is home to Tinker Air Force Base. And Tinker has made use of some innovative technologies like augmented reality to smartly design military construction projects like the Bomber Agile Common Hangar. Augmented reality has allowed Tinker to identify some unforeseen site conditions well ahead of time, which will reduce the cost and streamline project timelines. Additionally, Tinker's Bomber Agile Hangar has the potential of reducing costs from not having to rebuild facilities and projects as often, thereby increasing the lifespan of these facilities. So I think that these innovative technologies have some incredible use, and I'm glad that to hear today that we're using some of them. One of the questions I have, and it's probably more for Mr. Healy and Mr. Richardson, is can you talk a little bit about the challenges that you face with actually getting into the DoD and utilizing these new innovative technologies? The process for engagement, is it challenging for you all to actually enter the marketplace to be able to sell your product?
We were fortunate that our relationship with the Navy actually began when this technology was still within GE. Obviously, GE has a massive relationship with the military, and then that contract moved over, and then we've subsequently been able to win additional contracts with the Navy going forward. What we've found, if we're doing it the organic path, the SBIR is the best place to start. But I do agree with your comment of, as a startup company, it's not necessarily easy to navigate the military.
Mr. Richardson, would you like to add anything there?
So the study we did for DASD examining barriers to the inclusion of innovative construction techniques in MILCON showed that perhaps the establishment of goals and metrics could facilitate the use of more of these materials. For example, like identifying a specific technology and establishing what percentage of MILCON projects would include said technology would be a way to overcome that barrier.
Perfect. Thank you. Shifting to Mr. Morrow and Mr. Hamilton, in your experience, have you seen regulations with green initiatives on military bases to include mandating certain environmental standards drive up the cost of MILCON projects?
So that it was referenced earlier, MILCON cost premium study. So when we evaluate the cost of MILCON, we kind of sort them into, these are legal reasons why military construction is sometimes more expensive. These are regulatory issues, and these are policy issues. And oftentimes, with respect to those environmental issues, it's the first cost versus the life cycle cost, and that analysis. So it certainly can drive first costs up, hopefully drive life cycle costs down. But those policy issues definitely are a contributor to that milk
There's
cost
no
premium.
guarantee, though, that those life cycle costs will go down. This is sort of an assumption or a conjecture based on information you have today, correct?
And any of those policies, there is a waiver process, and many of them are changing right now, but yes.
Mr. Hamilton, would you like to?
I agree with what Mr. Morrow said. I think that we often, as we look at the use of our facilities, the length and the variety of missions that a given military facility will experience over the life of the facility are very different than what is experienced in private sector. And so the life cycle cost becomes really much more important than the initial cost. And sometimes those investments that are driving costs up, and many of them do have statutory or policy drivers, but many of them do have reasons that pay off over the life cycle of that facility. And so we try to look at those two different components and balance the needs of the military for a given project.
Would it be more helpful if you had flexibility, though, to make those decisions without the mandates or policy directives that are included?
Yes, ma'am, flexibility is always valuable.
Thank you. Lastly, Mr. Hamilton, in your opening remarks, you mentioned some statutory requirements that do need to change to allow more flexibility in the use of OTAs. Can you talk a little bit more about that?
Yes, Congresswoman, thanks for the question. I think this is an area that we are really looking hard at because, as Mr. Morrow said, we rely on industry to bring innovative techniques, constructions, materials to our projects. As you highlight, industry members are often hesitant to do that because there's risk in proposing those new technologies. There's risk in not being selected. We're trying to make our requests for proposals have selection criteria that favor innovative solutions that drive down costs and speed delivery. But there's still a familiarity because usually that partner is coming in not as a general contractor, they're coming in as a subcontractor or a vendor. And so they have to form that relationship, and the general contractor has to be familiar with that technology and feel comfortable in overseeing that in the project that they're responsible for. And that sometimes takes time. And so I think things that partner that relationship help facilitate innovation. The other point that I think is really important that I would make is that our current contracting requirements, some statutory, some regulatory, make it very difficult for us to bring constructors in early to partner with designers to walk through those means and methods and alternatives and go through the use cases that might drive down cost and speed. And so additional flexibilities that allow us to award a construction type contract partnered with the designer early in the process would be helpful to bring innovation to projects.
Thank you. And Mr. Chairman, I think it would be great for Mr. Hamilton to maybe give us some additional examples of how that could be utilized and what policy directives we may be able to implement to help achieve those long-term goals. So with that, Mr. Chairman, I yield.
Ms. Escobar, welcome.
Thank you so much, Mr. Chairman, Madam Ranking Member. I am thrilled to be on the Appropriations Committee and on this subcommittee. To our witnesses, thank you all so much for sharing all of this great information with us. I get to represent Fort Bliss. It is a premier installation, and the 3D barracks that were printed on Fort Bliss are really exceptional, and was proud to be on site for different components of the project. And I'd like to invite any of my fellow committee members who'd like to come and see them to join me at Fort Bliss so you can take a look firsthand at the quality of the work. We are all wanting to find as much efficiency and savings as possible. I've been so alarmed and concerned about the way that it's being done right now by the president and his buddy, Elon Musk, with the mass firings of watchdogs and people with key important experience. I think that costs us money in the long term. It doesn't save us money. But the conversations happening in this committee right now are what could actually save us money. If we take the information that we learn here and actually put it into action. And we have data from our district, from Fort Bliss, about the MilCon projects there. And they are one example of where this subcommittee really could find some key savings. Many of the military construction projects, and this is true across the country, end up costing anywhere, in El Paso, our data shows, from 68% more than what's happening locally to 500 times more than what is happening locally. When we compare housing built at our local university, same square footage, kind of same parameters, to barracks construction, the cost differential is shocking. So there are huge opportunities for us to change things up, and you all have given us some good examples. I think among those opportunities, we can require comparative market analysis for all facilities improvement plan projects. We could empower a privatized housing partner to build barracks, as an example. We could establish major construction intergovernmental service agreements with local governments, as an example, but 3D printing is another critical example. So, Mr. Morrow, would love to dive in a little bit on this with you. What kind, or actually, you know what, I'm gonna skip to the second question that I was planning on asking you, but what latitude do you think installation commanders need in order to utilize more 3D printing for things like barracks or for other construction projects? When I was on site after the ribbon cutting, I asked the folks there, same question. What were the impediments? What are the areas of opportunity where we can expedite this more? What do we need to do in order to make more projects like this successful and possible?
Thank you, Congresswoman. That's a great question. So our installation commanders and our garrisons are the requirements generators for all of the MilCon projects that eventually come to the Corps of Engineers or to NAVFAC for execution. So it really starts with, what are their requirements on site, and if they can shape those to be conducive for innovative technologies. So a lot of it has to do with, multi-story construction is going to be more problematic. The mass timber has its limitations on how large a building, but there's nothing that prevents them from, creating a campus environment or something slightly different. So again, what we encourage people to do is be as performance-oriented in developing those requirements as possible and not as prescriptive. And when you do that, then it opens up opportunities for new ideas, innovative technology, et cetera. And I did just recently meet with our construction field team out of the Fort Worth district. Tremendous set of exemplary professionals. So thank you for those kind words.
Thank you. I'm out of time, but I think it would be important at some point to hear from all of you. What are the barriers to making sure we move on this opportunity quickly so that we can focus on eliminating those barriers? Mr. Chairman, I yield back.
Thank you, Mr. Chairman. Thank you, gentlemen, for being here with us this morning. Very fascinating topic to me, and there's also some transfer over with the Corps to the Energy and Water Subcommittee I sit on. Mr. Hamilton, Mrs. Bice stole the question I was going to ask you, because I know in your testimony you talked about statutory changes needed. I'd love to follow up with you further on some of those, but I know, Mr. Martin, looked like you were chomping at the bit to hop in there too from the Corps' perspective. What are some statutory changes we can do to assist you with this process?
So Mr. Hamilton referred to getting construction contractors involved early in the process, and we can do that within federal acquisition regulations, but sometimes we have to really contort ourselves to make that. So we have ECI contracts and what we refer to as IDAC contracts, integrated design and construction contracts, but it does require a lot of extra contract administration and extra hoops to jump through. So other transactional authorities, we have a MILCON construction pilot for all the services for OTAs. Again, it goes back to that comment, the more flexibility we have, just like when if we tell a contractor exactly what we want, we're going to get what we ask for. If we tell them the requirements that we need, then we get those new ideas. The same is true on the acquisition side for NAVFAC and USACE. The more decision space we have and flexibility, the more innovative we can be in bringing those to bear. So I would say right now we can't really do progressive design bid build, which is a common delivery method in industry within the constraints that we have other than through an OTA. So that would be an example.
Okay. I look forward to following up with both of you and working with staff. So if there's specific things we can do to assist in that process, and we need to do it. Let's see, Mr. Richardson, you talked about DOD needing a roadmap. Can you talk a little bit more about that? How can we assist in that, and what would that look like?
Thank you, Congressman, for that question. So the roadmap that we envision would look like the National Defense Science and Technology Strategy. So that strategy identifies critical technologies for national defense. Commercial industry leads the way in the development of those technologies. Those technologies are shared. That's the strategy. Is you can look it up on the internet, and because those are shared and available, we see academia, we see the Department of Defense, and we see industry innovating in that space. So something similar to that, but for MILCON, which would include the identification of technologies that would be critical to improving MILCON performance, would be what I recommend.
Okay, great. And we look forward to working with you on something like that as well. Mr. Healy, thank you for your presentation. I was not familiar with what you're doing, and I'd love to learn more. I'd love to get a deeper dive on it. Sounds like you've figured out the better and the faster at scale. Will this be cheaper? It seems like it would be, just with all the problems it solves.
So we expect that upfront cost will be more than a conventional diesel generator, but then it really comes down to what's your ROI, what's your payback, and there's two key advantages that we're offering. So one is that improved efficiency, which means you're just going to use less fuel, which is the majority of cost of operating a generator is the fuel that goes into it. And then the second is the lower maintenance. So we're finding that depends on the industry. Actually, in military applications where fuel is very expensive, in some instances, it's going to mean you're going to have a faster payback. But in normal industries, we're seeing it's in a few years that you actually break over and it's a positive return on your investment.
Do you feel that government contracting is set up to allow for the long-range horizon view, or is it just an up cost, whoever's cheapest to produce gets it? I mean, do you feel that we factor ROI into as we evaluate different options?
I'm probably not the best to comment on it at this stage, just because of where we are, where we just have moved into the commercialization phase of things. Up to now, it's been more of the development phase working with the Navy. But one thing to share is additive manufacturing, 3D printing, it's new, right? And so if the military is going to demand volume of these type of solutions, that means the suppliers need to go out and procure 3D printers, set those up, and that process can take over a year to do. And so any vision or any kind of visibility into the horizon of demand and volumes is extremely helpful, because this isn't just hire contractors to go build it. This is go buy new machines, new equipment that will be better at manufacturing.
Okay. Carno likes cold, so how about the moon or Mars?
Yeah, so outer space is something that's on the theoretical. We think it can be done, but time will tell. We got to get things deployed here in the U.S. first.
Roger. Thanks. Mr. Chairman, I yield back.
Thank you, Mr. Chairman. I am truly honored and excited to be on this subcommittee, and I have the great honor and responsibility to represent Marine Corps Base Camp Pendleton in beautiful Southern California. Just a couple of weeks ago, I toured some of our barracks, and they need help. So I'm very excited to be on this subcommittee, in part to see what we can do about the barracks there on base. We've got about 125 of them, and about half either need to be completely torn down or thoroughly rehabilitated. The Marines that run the base, they talk about the barracks as operational necessity. No longer do they use the term quality of life. It's operational necessity. It's about readiness. And a lot of these junior enlisted Marines and sailors are living in subpar conditions. You've got, HVAC systems that don't work. You've got mold. I toured one building where Marines had been living as recently as just a few months before, and it's just unacceptable that we would continue to have barracks in that shape. Towards that end, I'm very interested in getting this fixed, and if 3D printing provides a way to do it maybe faster and cheaper, that's of interest to me. But I wanted to ask, and maybe Mr. Richardson, I'll start with you because you had some of this in your testimony. Camp Pendleton, we've got multi-level barracks, bigger buildings. I was talking to my colleague and friend, Ms. Escobar, about the Fort Bliss barracks. Has there been any testing of larger barracks, larger facilities? Can you tell me anything about higher initial costs, size constraints? Obviously, in California, we have these things called earthquakes that we're always concerned about, and then maybe whatever additional regulatory approval would be needed to do something like that.
Thank you for the question, Congressman. We did not, as part of the study I've mentioned, examine any specific technologies, but what I can tell you, and I know Mr. Hamilton or Mr. Morrow can comment on, if you're talking about building multi-story facilities, you're going to be limited to what innovative techniques and materials that you can use. For example, I believe the concrete printing is limited to one story.
One story.
One story now. However, laminated timber is not.
Anybody else want to comment on this? Thank you.
I would just say that the current requirement is single-story seismic zones A and B, so potentially problematic, but more testing could result in increased seismic zone areas or multi-story building. And for the Corps of Engineers, that testing is done out of our construction lab in Champaign, Illinois. And those people are amazing, and I would invite anyone on the subcommittee who would like a tour or to visit the facility. They would love to have you.
And can you reinforce the 3D printed concrete with steel as you would in a normal building?
It is reinforced with steel.
And what are the constraints on multi-story are what?
There, lack of testing.
Lack of testing. But that's going on right now in Champaign?
That's the source where the Corps of Engineers does all its construction testing. However, unless we have funding and a requirement, so they're working with industry every day, but we have to have a requirement to work against.
Go ahead. I know you're eager to get in.
I was just going to say, sir, that I think today the gantry crane printers are generally limited to one story, but there's a new printer technology that's been developed and is in testing right now that's more of a single arm that can print up to 27 feet tall, and so that will allow us to get up to a second story, would allow you to print roofs. They're testing that technology today, and I think as that gets tested and we have analysis of the seismic resiliency of it, that'll open up new doors to much bigger use.
The folks there on base tell me that if they were to redo the roughly half of the buildings, we're talking about well over $1 billion. The Barracks 2030 initiative says everything has to be redone by 2043. Any thought on the initial startup cost for the 3D printing alternative, and then also when you think it might be commercially available?
If I could, sir, I think I'm very familiar with Camp Pendleton. I rebuilt a lot of the barracks there, sort of the last generation.
So you get it.
Built the hospital there, so I appreciate your comments.
Did a great job with that.
I think in addition to 3D printing, industrialized construction is very well suited to the Marine Corps Barracks program. It's an opportunity to have standard designs, to build modules that you can have fabricated in a manufacturing environment where you have the workforce, you have all the industrialized, computerized machinery, and you send those modules out to be installed on the site. A general contractor puts in the site work, the slabs, and really assembles the modules. And I think when you look at the long duration barracks program that the Marine Corps is talking about, really recapitalizing their entire barracks infrastructure, that's ideally suited for that kind of event. There are things we need to do to help that industrialized manufacturing or construction capability in the United States take off and take hold.
So we're out of time. I don't want to run long on my very first hearing, but I look forward to further conversation with you. We'll take that back, and I'll yield back.
Mr. Lord,
Thank you, Chairman. I have to admit, I come to this first hearing with a little bit of bias on this military construction and VA subcommittee. My bias is informed by my years I spent in the Navy. I deployed to the Western Pacific in 01, 03, and 05. And just a few months ago, I was able to visit some of the bases 20 years later that I was deployed to, and was left with a little less energy seeing some of the infrastructure there had been left abandoned, dilapidated, and is in dire need of our support here. And I appreciate the witnesses and your expertise and your experience in helping to inform us here on this subcommittee panel on how we in Congress and our services can do a better job raising our standards. Some of the facilities I visited have those dilapidated structures, specifically in Japan, a number of them. And those dilapidated structures detract from their operational value, and they're outright dangerous and unusable. Rightfully so, the Indo-Pacific Command is a large focus of our Department of Defense. They're anticipating and deterring threats from the CCP, Russia, and North Korea. Mr. Hamilton, given your expertise as one of the Navy's top engineers, how can our military, with Congress's support and the Navy specifically, be more agile in terms of acquisition and adoption of novel construction technologies, especially in that very important Indo-Pacific Command?
Congressman, thanks very much for the question. I also was stationed in Korea and in Guam and deployed into the Pacific Theater, and so I'm very familiar with the challenges that they face there. I do think that we need to have a long-term capital plan to modernize those facilities. As you said, many of them are far beyond their useful life, and we need to be providing facilities that can replace those and take the modern weapon systems, the modern missions that are expected to be deployed in those areas. I think contractually, I do believe that the industrialized construction technique that I talked about earlier is one that is very applicable to overseas, especially in the Indo-Pacific theater, where we could fabricate many of the components or modules in the States and have them shipped for installation. I think it gives us the ability to be very agile so that those can be configured in different ways to meet different missions, and we can be very responsive to the military commander's needs and where the priorities are as they change over time.
Thank you, sir. Mr. Richardson, we were chatting before. You graduated 3 years after the best Naval Academy class that has ever been. Appreciate that in your service in the Navy Civil Engineer Corps. Can you add some perspectives to how the Navy, the military, specifically with Congress's support, can help improve get more projects done on time, within the right quality and the right cost?
Thank you for that question and comment, Mr. Congressman. So yeah, there are certainly innovative technologies that could improve performance. I wish I was able to explore more of these technologies in our study. But going back to some of my earlier comments, establishing or identifying some of those technologies that could assist in perhaps better construction performance would be of value.
Thanks. And Mr. Morrow, I only have about a minute left, but with my remaining time, similar question. Where can Congress help our services knock down some of the bureaucratic red tape or otherwise expedite the military construction as it relates to delivering projects that are at the right cost, at the right time, and the right quality, sir?
Thank you for that question. So what we're doing right now is trying to identify why MilCon costs more than private sector and really produce as factual a document as possible. Here are the laws that impact our costs. Here are the regulations that impact our costs, and here are the policies that impact our costs, so that those policies can be changed if the new administration chooses. Those regulations can be addressed through rulemaking, or those laws can be changed. So I think my personal position is I'm agnostic on those things. You know, we're here to serve and to support the administration and the Congress, but we want to present you the facts so that you know why that MILCON premium exists.
Thanks so much, sir. Appreciate, gentlemen, your expertise and your participation in today's hearing. Chairman, I yield back.
Thank you, Mr. Chairman, and gentlemen, thank you for being here today. Mr. Morrow, you mentioned in your written testimony, you talk about the important role that ERDIC plays. I'm from Mississippi, and so I have had the opportunity to visit the facility there in Vicksburg to see the great work that they do. And so my question to you is, as a body, how can Congress, how can this committee specifically, what can we do to support ERDIC's mission and to make sure that you have the resources that you need to, as you say in your statement, to see that we continue to discover, develop, and deliver trusted engineering and scientific solutions to the warfighter and the nation?
Thank you for that. So ERDIC is an amazing organization across the globe, but they serve many, many stakeholders and customers, and like the rest of the Corps of Engineers, primarily operate on a reimbursable basis. So essentially everything that the Corps does is based in law. So if there's a requirement and somebody goes to ERDIC to execute that requirement, they get super excited to do that. So working with industry, some of the pilots, whether it's mass timber or additive construction, they all, come to ERDIC through some legislative authority and appropriation, and there's no better place, in my opinion, for that work to be done. But they do need that specific authority and appropriation for any of their work.
Thank you. Mr. Hamilton, want to ask you one or two things real quickly. You say in your opening statement, you kind of echo some of the remarks of Mr. Morrow. You say that the primary role is to support our warfighters home and abroad, to make U.S. warfighters more lethal, adaptable, and resilient. First, thank you for both of you for refocusing that mission, to making sure that we're putting the emphasis on the warfighter, that we're providing them what they need to when we place them in harm's way, that they have what they need to be able to perform that mission and to come home to their family safely. And then you talk about different initiatives, some that are current, some that are evolving, prefabrication being one, additive construction, modular construction, all things in which we currently are either operating or intend to operate in the near future. One of the facilities that served in my facility is Meridian Naval Air Station. They are home of the training Air Wing 1. Many of our naval aviators begin their initial training there in Meridian before going on for more specialized training. One of the projects there that we're working toward is one of the hangars there, Hangar 2, needs a new roof facility because of age, because of sometimes some of the inclement weather that comes through, particularly in the spring and fall, known as tornadoes and wind gusts. We used to think that Hurricane Alley was there in the west. I believe now it's shifted to coming through the southeast. And so often see those types of weather conditions really exacerbate the condition of some of the buildings there. And so as we look at these innovations, we know some of these innovations are probably better used for new construction. And others for things such as renovations to Hangar 2 or renovations to other buildings. Kind of talk me through how these innovations can be used both, again, for the new construction, but also as we're looking at repairing and renovating existing buildings on military facilities.
Thank you, Congressman Guest. I think we have a real challenge across all the military services, but certainly from my place in the Navy and the Marine Corps with aging infrastructure, obsolete infrastructure, more repairs than we can afford to make in the time frame they need to be made. And so there's always a challenge for us prioritizing. And I would say as we've faced some very costly things like the Mawa typhoon in Guam, where we've had to make some emergency repairs to the glass breakwater and other things that draw away from planned renovations and modernizations, like the hangar roof that you spoke to. I do think there are opportunities as we go forward to build more resilient facilities and more facilities that will last longer, because our facilities, we may build them for 50 years, we tend to use them for 80 or 100 years. And so we had to take that into account. And I think that gets back to the life cycle cost analysis, that when we invest in certainly something like a roof, we want a roof that's going to last a long time, because it's probably going to be in place for a very long time. But I think that we have to work through that in the, both the repair of existing facilities and new construction, and they are related, but they are different. I do believe we have more opportunity to apply some of these new technologies in new facilities, because it's very difficult sometimes to incorporate or blend these technologies with some of the existing facilities. But we do have polymers and fibers that we are developing that allow us to reinforce and strengthen existing materials like roof trusses or other materials that you might find in existing facilities that allow us to extend the life of them. And that's another area where I think we have benefits to do things faster and cheaper with some of the technologies that are being developed.
Thank you very much. With that, Mr. Chairman, I yield back.
Thank you, Mr. Guest. And I want to thank the panel for being here today. I have a real interest in this. I apologize for my voice. It'll get better tomorrow, I hope. We look forward to working with you. I want to come visit your lab. Smart things, new things that work good and are mobile are fantastic. And we got to make it work. The islands are going to be a challenge for the Navy and the Army and some others. Guam is the typical example. Labor issues, cost overruns, all these things are going on in Guam. We got to get that straight. So I'm hoping to take this panel over for a visit to the islands again and keep that on our forefront, because it's real issues. Thank you all for being here. I appreciate every one of you. Got one question for you. If we were using your generators when the power went out in Texas, would they have worked?
They would have worked, yeah. We wouldn't have had the freezing buildings and facilities that we had, and the health issues that we had as well.
Okay, good. Thank you. Thanks to the panel. We're adjourned.